Welcome to this Forge College Explainer. So, if you were with us for our last lesson, Testable and Efficient Function Workflow, congratulations! You survived the heavy math. You already know how to separate pure helpers from state-changing functions without breaking a sweat, and you know exactly how to keep those state rights tightly grouped. Well, today we're taking a step back from those low-level tactics. We are getting ready to draft the actual blueprint for our capstone contract. Let's get into it.
I'll just figure out the state changes later. Yeah, said the broke developer. We've all been tempted by that cowboy coder trap, right? You know the exact feeling. You just want to start mashing the keyboard and figure out all the complex state changes on the fly. But guys, winging it on the blockchain isn't just a bad habit. Your mistakes literally cost real gas and real money. A bug here isn't just some Tuesday morning glitch you patch over coffee. It's a permanent financial disaster.
So, to avoid going broke, we are building an engineering assembly line today. We're going to forge a bulletproof blueprint before we write a single line of production code. We'll be looking at the blueprint before the build, capturing your business rules, classifying your contract functions, modifiers as your gatekeepers, the failure mode checklist, and lastly, your capstone master plan.
Starting off with Section 1, the blueprint before the build.
Look, ad hoc cowboy coding leaves your smart contract wide open to exorbitant fees, nasty exploits, and just endless headaches. It's basically like trying to build a skyscraper with zero architectural drawings. No way. Instead, treating your contract like a highly calibrated physical machine with proper planned engineering guarantees an optimized, fully testable wiring diagram. We want to completely eliminate ambiguity here. That way, when you finally sit down to code, the whole process is smooth, predictable, and totally deterministic.
All right, moving to Section 2, capturing your business rules. Before we even think about writing functions, we absolutely need our raw materials. Like, what does our product actually do? Abstract product requirements need to map directly onto explicit function signatures and modifiers. Take the business rule, list item with positive price, for example. That translates seamlessly into a mutator function guarded by a valid price modifier. Or, say, cancel listing by seller. That becomes a mutator guarded by an only seller modifier. We are literally translating fuzzy human logic into unbending, mathematically verifiable blockchain constraints.
That brings us to Section 3, classifying your contract functions.
To keep our machine super organized, we're breaking our functions down into 4 distinct roles. First up is the controller. Think of the controller as the brain of the operation. It delegates tasks, it manages asset transfers, and it coordinates exactly where and when state rights should happen. But here's the golden rule. Keep your controllers extremely thin. They shouldn't be doing heavy, complex math. Nope. They should purely focus on traffic coordination and keeping the execution flow moving.
Next, we have the helper. Honestly, helpers are a blockchain engineer's absolute best friend. They handle all the complex math and internal logic without ever touching the blockchain state. Because they're pure or view functions, executing them costs absolutely zero gas. Zero! This makes them incredibly fast and totally painless to stress test off-chain with thousands of automated unit tests.
Then we get to the mutators. If the controller's the brain, mutators are the muscle. These are the heavy lifters actually moving the blockchain furniture around by actively writing to the state. And because they're doing the physical labor, well, they are the ones that cost gas. State rights are the most expensive opcodes in the Ethereum virtual machine, but by isolating your mutators into strict, categorized functions, you'll know exactly where your gas hotspots are going to be, long before you even deploy.
Finally, the getters. Getters are basically just peeking through the window at the data without disturbing anything inside. They provide read-only access to the current state. This lets your dApps front end, or even external smart contracts, quickly and cheaply query what's going on under the hood without risking any accidental state manipulation. Safe and simple.
Let's slide into Section 4, modifiers as your gatekeepers. Every machine needs safety valves, right? Otherwise, it explodes under pressure. Imagine this scenario. What happens if a buyer manages to purchase an item that was actually already sold a block ago? Yikes! Without strict preconditions, an edge case like this causes logic loops, breaks your state variables, and violently drains funds. It's literally the stuff of Web3 developer nightmares. To stop that nightmare dead in its tracks, we implement strict gatekeepers. Take an only available modifier, for example. It strictly checks if the item is not sold. If it is sold, boom,
It halts execution immediately and reverts with an exact string, like item not available. By hard-coding these exact revert strings up front during the planning phase, your unit tests get deterministic hooks to look for. Believe me, this saves you from tearing your hair out debugging vague, unhelpful failure messages or obscure hex errors down the line.
Next up, Section 5, the Failure Mode Checklist.
Even the most brilliant blueprints need a stress test. You absolutely must create an emergency diagnostic protocol for your team. Getting unexpectedly high gas costs? Run the profiler immediately. Got a failed token transfer? Go inspect your fallback behaviors. Reverted purchase? Check those modifier strings we just talked about. Drafting this exact checklist right now gives you an instant step-by-step runbook to rely on when your tests inevitably flash red, because they will, and you'll be ready.
So let's lock in this complete workflow. Step 1. Capture your business requirements. Step 2. Classify those functions by their roles. Step 3. Define your gatekeeper modifiers and specific revert strings. And Step 4. Attach your tests. Really drill this exact sequence into your mind. This pipeline is exactly how you systematically convert absolute ambiguity into a perfectly deterministic, totally stress-free build process.
And finally, Section 6, your capstone master plan.
This is it. The ultimate goal of our entire drafting phase, the annotated skeleton contract. It contains all your structs, your mappings, your empty function signatures, and your modifier definitions. Now sure, this wiring diagram is totally empty of internal business logic right now, but make no mistake, this is your ultimate weapon against critical bugs and spiraling gas fees. It lets you see the entire architecture of your project from a bird's eye view, catching structural errors way before the difficult coding even begins. It strictly dictates the boundaries of what you are about to build.
So the big question, are your blueprints truly ready for the build? Have you mapped your rules, assigned your roles, and completely locked down your gatekeepers? Remember, a sloppy plan makes a vulnerable contract, but a solid engineered plan makes the coding phase an absolute breeze. Will your next contract be an unbreakable fortress or a bug-filled bounty for a hacker? Think about it. Thank you so much for joining me on this Forge College Explainer. To master more Web3 engineering skills and dive straight into the actual implementation of this skeleton, be sure to visit forge.college. See you in the next one.